Dear colleagues, ladies and gentlemen, good morning or good evening. Welcome to the World Federation of Engineering Organization Climate Change webinar on the WFEO Code of Practice, Principle of Climate Change Adaptations and Resilience for Engineers. About 1.2 billion of people are at the high risk from climate-related hazards, but much can be done by the engineers to make people, community, or countries more resilient. An assessment of 44 countries show that in spite of growing attention and adaptation planning, most countries are still lagging in implementing resilience intervention, especially those related to policies and micro-fiscal dimensions. Adapting current and future infrastructures to be resilient to extreme weather events and long-term climate change over their long service life has become a societal imperative. Engineers need to understand and play a key role in achieving this goal as an integral part of practice. WFEO is committed to raising awareness amongst engineers about potential impact of climate change, and this related to engineering of existing and future infrastructure developments. As such, the WFEO Model Code of Practice on Principle of Climate Change Adaptation for Engineers was developed and published to provide practice guide to engineers to consider the implications of climate change in their professional practice and creating a clear outcome of these considerations. Today, we have the pleasure to invite David Lapp, a member of the WFEO Working Groups on Climate Change, also an associate of Climate Risk Institute, to share with us the WFEO Code of Practice. This webinar is organized by the World Federation of Engineering Organization in collaboration with Engineering Institute of Canada. David is a professional engineer graduated with Bachelor of Applied Science in Geological Engineering from University of Toronto in 1978, following a career of nearly 20 years in consulting engineering. David joined Engineer Canada in 1997, and for the subsequent 23 years, he assumed a variety of roles in the international affairs, engineering qualification, co-authoring several national and international practice guides related to sustainability, environmental stewardship, and climate change. So without further ado, I will pass on the floor to David.
Thanks a lot. Welcome everybody. As we were saying, good morning, good afternoon, or good evening, wherever you are. It's a great pleasure to be here and to present this code of practice, which we wrote as on the committee of engineering and the environment about 10 years ago. This webinar is an attempt to raise the profile of that document, to make more engineers aware of it. It's based on principles which hopefully don't change over time. And as I was reviewing this recently, found that these principles still remain true, and I think even more relevant today than maybe even 10 years ago. So we'll start the presentation. I'm going to ask Ivan to put up the opening page for me. Yeah, so we'll go to the next slide. Just to give a bit of an outline, I'm going to put in some introductory remarks, then talk a little bit about the development of the code, and particularly its status and authority, because code sounds like it's authoritarian or it's a mandate, and it's not intended that way unless national organizations wish it to be so. We'll talk about the existing principles. There's 9 of them. There's a lot to unpack in this code of practice, so I obviously, in the time I have, I can't get into extreme detail. I will go into detail in some of the principles more than others, but I certainly will touch on all of them. We have two new thoughts around principles and concepts because we're at the moment, the WFEO Working Group on Climate Change is revising and updating this document to reflect the last 10 years. A lot has happened in terms of the availability of tools and information and the interest and the urgency to deal with this, and engineers being a key player in that. Then I'll have some closing remarks, and then we'll get into questions and discussions. So let's go. So let's go to the next one. Okay, so I'm going to give everybody a kind of an engineering 101 because I think it's important to understand and why we need to deal with climate change and climate changes to infrastructure. So you start off, as a trip, typically you have you design your infrastructure to have a certain capacity to handle the load, which is the next iteration. Yep. So of course, capacity has to exceed the load for the infrastructure to be safe and to account for uncertainties and things like the properties of materials or the foundation upon which the infrastructure is located. We add a safety factor, which is the next click on there. So we have a good amount of capacity to meet the load. Now, of course, infrastructures last for long periods, 20, 50, 100 years. So they weather, they get used more. So there's a reduction in the capacity through use and weathering and so forth. And that happens as time goes on. Another one there. So meanwhile, your load increases because the use of the infrastructure increases, population increases, and then all of a sudden you have a severe weather event where the load exceeds the capacity, and bingo, if you have the cloud there, it's a potential failure condition. So it's the weather event, perhaps a severe weather event or creeping climate change that can result in the load exceeding the capacity and a potential failure. So that's why we need to really consider climate, because it's an additional load on our systems, and because it's changing, it's not static. Our weather is non-stationary. And we'll show that in this diagram here. So if we have this diagram here, it's a probability distribution function for a climate parameter with a mean, and as climate changes, next one. I should also mention that, of course, with things like design codes, you have an infrastructure threshold beyond which there could be that failure. So there's a potential failure condition, a probability there, that red area. That is something that you keep to a minimum. You can't necessarily completely eliminate the failure, but you get it to a very, very high factor. So that's what we have as kind of an existing condition. And then when the climate changes, so the mean changes, increases, the distribution changes. Next click. And you end up having an increased probability of that infrastructure threshold being exceeded. So this is what the climate, when it shifts that way, then you're increasing the possibility, if you do nothing, of course, and if you don't account for it in your design, then you can have this potential failure condition, or at the very least, severe damage, loss of service, and so forth. So this is what we have to try to understand in our analysis, is that the climate is changing, how much it's changing, how fast it's changing, how often, for example, extreme weather events happen, these sorts of things. So we absolutely need to have our attention on this because of our infrastructures, the length of time they are in service. This isn't just 5 or 10 years, we're talking 25, 50, 100 years. So, and in that time, it's guaranteed, and we know that the climate is going to change. So how do you deal with this uncertainty? Next slide. And this became really the kernel of the idea behind how do we as engineers deal with the uncertainty of climate? Well, we determined, and we did this work in Canada, that climate risk and vulnerability assessment is a key tool to understand what the changes are in the climate and what the consequences are. So here you have a risk matrix where you have a probability of occurrence of a climate event. In this case, it's a scale here of 7 by 7, but it can be 5, 3. There's lots of different risk tables that exist. So that part is sort of locally local best practice. So you start off with a flood that has a low probability of occurrence, but a very high consequence. Then through climate change, the frequency of that flood increases substantially, shifts it over into a higher probability with an equally devastating consequence. So you're now into a zone of red there, the high risk zone. And in order to mitigate that risk, one must do something. And this is where adaptation comes in. So you put in adaptation, and what it does is it reduces the risks to an acceptable level. The acceptable level of risk, so just click the one thing there. So now through the adaptation, you've now reduced that to a much lower consequence, even though the flood is there. And so it's taking measures through adaptation as engineers. So we have a key role to play in the adaptation space here. And in this case, wanted to also to explain, and people would know this for the most part, but adaptation is one might say managing the unavoidable. These things are going to happen, and we need to adapt and be resilient. Meanwhile, mitigation is trying to avoid the unmanageable. So we're trying to keep our climate change to the least possible. I always say mitigation is global, adaptation is local. So mitigation requires a collective world effort to reduce greenhouse gases, for example, and we're trying to do that. We have international agreements, but really what we can do as engineers, and for the most part, because that's a process, mitigation is almost a political process, adaptation can be implemented locally, regionally, nationally, to deal with infrastructure. So I really feel that engineers have a key role and almost, one might say, a priority to deal with climate change through adaptation, because you can control, as one might say, the impact in your community or your infrastructure, whatever scale you're looking at. Next one. Just click through it till we get to the end, Ivan, because I don't want to spend all the time just going through each step. So just click it a few times there. Yeah. So what you have here is some work that was done a number of years about when should you intervene with respect to adaptation measures, and what does it result in costs and cost savings. So if you see the black line there, you have the service life of the infrastructure and its functionality. Of course, by the end of its service life, its functionality is reduced to a small level. Somewhere in the service life, you have a climate event, an extreme event. Sorry for the graphics here; it's a little sketchy. And if you haven't done anything to intervene or prepare for this climate event, then the functionality of the infrastructure will decrease to perhaps complete loss, or certainly extended loss of service, and it's going to cost a lot of money to bring that infrastructure back to some level of functionality. If you intervene, I may click again, Ivan. See here, yeah. So if you do some adaptive measures kind of in advance or in anticipation of extreme weather events, then first of all, the impact on functionality is less, and the recovery is quicker, and the cost is less. So this is what I guess one might say the argument is for doing adaptation in advance of potential climate impact events. In the end, you save money, you save functionality, and so forth. So it's really, I think, incumbent for engineers to argue to clients, even though we don't have the final decision, but at least to say to our clients, the owners of the infrastructure, hey, we got to make sure that we can withstand climate impacts as much as possible so that you don't lose your infrastructure for an extended period of time, or it isn't destroyed and then you have to rebuild. So let's put in some efforts, beef up the design, maintain and operate it in a manner that will minimize the impacts and the recovery from climate events. Next one. Yeah, so it's just kind of like, different scenarios of intervention there that are displayed. And there's a reference in the bottom there, Ivan, just if you click it one more time, so if people are interested, they can look into that reference. But I think it's very, very interesting and illustrative work as to the advantages of adaptation as part of design, operations, and maintenance in advance of climate events. And of course, you have to understand the climate and how fast and how much it's going to change. And there's a lot of uncertainty in that. There's a whole body of work and people that are working on that. And of course, we as engineers need to work with those people to understand what those projections are going to be for us to anticipate and adapt our infrastructure. Next one. So just to go now, focusing in on the practice, the Code of Practice. So we developed this document about 10 years ago in the Committee on Engineering and the Environment, and it was approved by the WFEO members in December 2015. It is on the website. I put the word buried because it's not obvious up front, and I would hope and I would advocate that we bring up the profile of that document to be more visible to people that this document exists. But there's the link to it. And also want to emphasize this is a model code of practice. This is not a prescription type document. It's a voluntary document, and so it's a model. A model means that you can use that document as it is or adopt it, modify it to see fit. And we encourage national members of WFEO to do that. And this document probably represents about 80% of the work that would be needed to adopt it for a particular country. You just need to make some changed references and so forth. So, or you can certainly just slap your own logo on it and say, this is what it is for us in our country, whatever, but certainly encouraging the folks to do that. To give you an example of where this has happened is in Engineers Canada. Of course, I work there. We have a mirror document to that particular to the Code of Practice, and it's referred to as a public guideline on principles of climate adaptation. And we, since that document was published, we've added a few commentaries around mitigation also. So it is a mirror document, and it is an example of how a national member of WFEO can take a document like this and adopt it locally for their jurisdiction. And as I mentioned before, we are updating and undertaking revisions to reflect the state of knowledge over the last 10 years. There's documents in there that are referred to that are more than 10 years old, and IPCC has published more recently and so forth. So that's part of the updating, is to make sure that we remain current with the current body of science and literature and practice and so forth. So next one. The authority. So what's the authority of this thing? Well, it's intended to inform and to provide guidance. And I think what it really does is it looks at it from the professional practice point of view. We're not looking at technical approaches. We're not really getting into how to do things, how to do climate projections, just that you need to do climate projections, for example. So because that field of how to do things is constantly changing and updating and evolving, and there's no way that a document like this could ever keep up with those changes. So it really takes it at the level of principles, which we hope don't change over time. And I believe that the principles we have there listed have not changed over time. They still are applicable and relevant. Maybe we could tweak the wording a little bit, and as we'll get into, a couple of modifications are possible as well. It also, I think, is a useful document for jurisdictions where there is limited legislation or regulation related to climate change. Some countries are much more advanced than others. There's others that have little or no guidance in this area. So I think this is the kind of document that, for those jurisdictions, engineers in those jurisdictions where there's really not a lot to go on from the government or whatever, you can use this document to help you really get engaged and practice professionally in this area, So hopefully it can be of help in that manner in those types of situations. It also, I think, one of the things you have as an engineer, of course, is we're not the final decision makers. So we have to convince our infrastructure owners, our clients, that adaptation is a good thing, and we need to modify the design to take into account these potential scenarios and risks. And so what you're really trying to do here is put their balanced competing interests. You've got the interests of the users of the infrastructure versus the owners of the infrastructure, and we're the engineers in the middle, trying to come up with the best way of course, first of all, making that infrastructure safe, but then also making it efficient, cost effective, and I think climate resilient. And it's, as I say, we're not the decision makers, so we have to try to convince our owners and operators, unless we're delegated that authority, to give the funding that's needed to perform this work. Next one. So as with documents like this, there's this kind of wording that's used, and it's the use and application. And so we use the word should in certain cases where it's a strongly preferred recommendation, but it's not binding. You won't be, if you don't do it, you're not going to be penalized for it because of the nature of this document. It's a voluntary document. However, it is absolutely possible for a national member to change the wording to be must, where it becomes enforceable and can be sanctioned. So there's nothing stopping. That's a way a jurisdiction can increase the authority of this document. But we as WFEO in this document can't do that. So that's as far as we're willing to go is the should level. Then of course is that kind of fits into the shall or must. So in certain cases, it's a legal requirement or compliance is required, potential for sanctions. So that's, you can make words like that. And then, of course, and you'll see in the document in other places, there's the word may, which is kind of like looking at several options and, thinking about whether you want to do that or not. It's discretionary, and, it's guidance. So it's trying to help you think about this and to help you make choices by offering some of these choices, but it's not telling you this is the choice. This is where you have to use your engineering judgment, which we'll talk about in a minute or two. And that's what's important here. So next one. So as I mentioned earlier, WFEO is not a legal authority in any jurisdiction. We are an international body of national engineering organizations and with some international members. We're the collective of engineers. We advocate and so forth, but we have no legal authority, and so this document has no legal authority. Just want to emphasize that. However, it can be, you can take it as an international or national member and make it so if you're so wish. So it's really, model codes, as stated here, are used to provide guidance on specific areas or elements of professional practice that have been mutually agreed among all WFEO members. So when they approve that document, there's over 100 members that approve that document as an overall guiding document. We have another code of practice on sustainable development and environmental stewardship, and perhaps in the coming months we'll have webinar about that particular code of practice, but here we're on adaptation. And as I mentioned here, you can adopt it in whole or in part, and actually, publish this document in your jurisdiction, distribute it to your engineers, have workshops, these sorts of things. WFEO can help you with that, and I'm happy to assist in that effort if it's needed or wanted. And yeah, so let's go on to the next one. So now we're getting into the document itself. So we have 9 principles. We describe the principle to begin with and amplify it. So we're trying to do it as a series of one-liners to keep it, precise and concise. And then we have an amplification, so further explanation. It's right, what do we mean by these statements? And then implementing actions. So the idea here is to provide you with some ways of thinking about these principles and how to implement them without getting deeply into the how to implement them. But what do you need to think about? Actions that can be taken, and of course, there's lots of room for additional actions that aren't listed in this code, or taking a subset, whatever you feel is appropriate, because every situation, every infrastructure is unique and requires, again, that's engineering judgment that we need to bring to those situations. Next one. So here are the 9 principles just listed, and we'll go through, as I say, a few of them in a little bit more detail. I don't have enough time to go into all of them in really any detail. So I really encourage everyone to read the document, and if you have any questions, we can always answer those, after, in the coming weeks and months ahead. But the goal of these 9, which was stated earlier, is that ensure that engineers consider the implications of climate change in their professional practice. So we're saying that you as an engineer almost always need to consider climate change, at least to say, well, we considered climate change and we found it not to be relevant, or it doesn't apply here. And furthermore, that you've documented that in a record. So it's not good enough just to say, well, climate change we didn't think was important, and there's no record of that. As an engineer, you need to document this decision, this rationale, because you could be, if you haven't considered climate change, there are potential consequences for not doing that. And in fact, climate change really affects most of disciplines of engineering one way or another. It is not just a civil engineering type of consideration. Electrical, mechanical, geological, most disciplines in one form or another have to consider climate change in their practice. So next one. So I guess first, kind of re-emphasizing the point, integrate climate adaptation to practice. Like, understand what's happening to the climate, like have a basic understanding of the climate science, the science of climate projections and weather, because you're going to need that if you're designing infrastructure. You're designing for climate parameters, and you need to keep up with at least what's going on there. You don't have to be a climate scientist, but at least you need to know what is scientifically defensible, and make sure that because you want to make sure that whatever climate information you are given, you have a way of either challenging it or a basis to accept what they're telling you is the best information available for what you need to do. And it really is kind of a day-to-day thing. You just need to think about it as you're doing your work, at the stages of design, operation, and maintenance, and also in procurement. And sometimes I think this is overlooked. Engineers do get involved in procuring infrastructure, and we're not always the designers. Sometimes we are the client in a way. And I think it's really a really important area for people to be able to know what to ask for when you're wanting to have climate adaptation incorporated into your infrastructure. So the area of procurement is a very, very key instrument in any infrastructure project. And so properly specifying what is needed and why, I think, is really important. And we all need to have that competence, because chances are at some point, one way or another, either as a client or a prime contractor going to a subcontractor, you're going to have to write a statement of work that includes the provision of climate. And so making sure that it's included, because if you don't, I think it's you know, it's let's just say missing and so needed. Next one. So implementing actions, well, here's a few just to give you a sense of what you need to think about. What are the climate parameters that could impact your infrastructure and how? And what kind of impacts it might happen? We see damage, loss of service, that sort of thing. What are we doing in the design to mitigate? You can't design a completely climate-proof infrastructure, so it's kind of a trade-off between design for resilience and operations and maintenance. We're maintaining this for many, many years. We have to have really good maintenance on this infrastructure to make sure that it remains climate resilient. So you got to think about the whole life cycle, both design, operations, and maintenance. And things like inspection, like making sure that we're inspecting things on a regular basis to see if there's any signs of weakness or failure or whatever. And some of it is not just about the hard infrastructure itself, it's also about the procedures and the policies of operating that infrastructure and the training of the people that operate and maintain it. These are all things that need to be factored into having a resilient infrastructure. And number 5 here is really important, and I'll say this a number of times: maintain a record. Document it. Don't just have it in an undocumented discussion. Make sure that you write these things down, because again, if there's any kind of issues down the road, or you're coming to redesign or rehabilitate the infrastructure, those thoughts and considerations on the record are extremely important. And of course, the last one is the good old engineering judgment. That's what we're paid for, is our judgment. And how do you make that judgment? Well, it isn't just a hard number. A lot of times, there's a lot of factors involved here, and it's of course the project parameters itself, but also things like what are the precedents for this infrastructure? What have other infrastructures done in that area? These sorts of things. Next one, because I'm moving. Got to move along here. Of course, a key tool that we have for design of infrastructure is codes and standards. And we know that this is a long process. To change a code or a standard it's a lengthy process. In Canada, we change our national building code about every 5 years. And only now are we really getting climate change into the codes, even though we recognize the impact of climate more than 20 years ago. So it takes a long time, and a lot of evidence has to be presented to make these code changes. And it's really because our historical weather is changing, and so we need to update it and project it going forward, because it's not staying the same. So that affects the codes and standards that are there. And there's been a lot of work done at the national level, international. ISO, there's a one ISO 14090 series of standards around adaptation and so forth. I would highly recommend, if you haven't had a chance to look at those codes and standards, they're a great starting point. And there's also all the tools, right, to actually do your work. There's a tremendous, I would call a plethora of tools and guides and so forth. And you need to, I guess, find the ones that you feel are work best for your area of practice. That's why we just can't make a recommendation on any one or the other than to say, find out what information and guidance is in your jurisdiction, your country, and work from that, because that at least reflects more local situations, because climate, of course, is not universally the same everywhere. It varies. Certain things are more important in areas than others. So, you just got to be aware of that and account for it. Next one. So again, find the latest codes and standards. You need to do that anyways as an engineer, is always keep up with local codes and standards, whether they're climate related or not. And I guess the other important thing about codes and standards to mention is this is the baseline or minimum. These are not maximums. These are the minimum standards to assure safety of infrastructure. But this isn't just about safety. This is about actually reliability, providing service, minimizing cost, minimizing repairs, and minimizing disruption. Because if infrastructure provides a service to people. So if that service is interrupted, then it has a huge public impact, even if it's not a safety related thing. So we have an obligation as engineers to actually go beyond just safety. And codes and standards only assure safety. They really don't get into beyond that. And so, again, as engineers, we need to look at that and say, okay, well, we need to probably be greater than that for a particular situation or parameter. Again, need to document what we're going to use, and that's where we go. That's how we need to handle it. And again, making a record of the adjustments. If you don't, if you're exceeding a code or standard, then you need to document that and provide the rationale. So next one. So professional judgment, of course, we've already talked about this quite a bit, but again, looking at both the current climate and the future climate is important. So the historical record up to now, particularly if it's existing infrastructure that you're rehabilitating, or perhaps you're demolishing and putting up a new infrastructure, but you've got a historical record of climate up to this point. And then, of course, you need a projection of the future, and the difference being the climate change. And again, documenting your judgment and decisions around adjustments is really important. And sometimes you don't need to make an adjustment, or you're not going to make an adjustment. And so you again need to document that. And as part of that, to help you in that judgment, you need to engage with outside experts for certain areas where you don't have the competence to necessarily make the assessment totally by yourself. Next one. So again, checklist of climate parameters. The applicability of the climate information is, you want to make sure you've got data that's relevant to your infrastructure, its location. Example of that is, a lot of data stations, historical records are widely scattered in some areas. In Canada, we have areas of hundreds of miles between climate stations, and so the climate at your particular location may not be represented totally by a station that's 200 miles away. So again, you got to think about that and say, well, looking at some of the other factors like topography, perhaps there's other records saying, hey, things are a little different here. So again, that's part of your judgment. And the again, this should be documented, whatever data you've used, and then again, putting it into a documentation form. Next one. So an important element, of course, is interpreting the climate and the information that's provided to you. And you can't do this as an engineer. There's very few engineers in the world that are climate scientists as well. I actually know a couple of them, and they're amazing people, but they're very, very rare. So you really need to work with climate scientists and specialists that have that knowledge of the climate itself, particularly in your area or your country, and also of projections and that sort of thing. They can provide you with the scientific rationale and the the scientific validity of the data that you're using or the projections that you're using. That being said, they give you a number, and often climate scientists want to do it to the fourth decimal place, but we don't need it to the fourth decimal place. But in the end, they give you a number, and it becomes your responsibility as an engineer to use that number, whether it's used as it is or you make that adjustment, as I mentioned before. And I would argue that all the numbers that engineers use in design, whether it's for climate or otherwise, whether it's based on a scientific formula or whatever, it's still a judgment to use that number. Is that number appropriate for my project? So anytime that you are looking at a number for a design, then you are making a judgment about using that number. One of the things about climate is it's a challenge still in the sense of the availability of climate, the quality of the climate information. Sometimes the records are not long enough to be, one might say, scientifically defensible. So you are going to have challenges in dealing with the climate. And in the early days, climate scientists and engineers couldn't talk the same language. They tended to have, we can give you this, but we want that as engineers. I think over the years we've come to a much better and closer understanding, and that's positive. And I guess the other point on the slide is just to say that don't use one climate projection, use a bunch of them, an ensemble approach, because climate models are inherently uncertain themselves, but if you get a collection of them and they're all pointing in the same direction, then that adds confidence to the projection. Next one. So again, we're designing to extreme values because that's, again, for safety, but also for damage and so forth. So a lot of this is around the frequency and intensity of extreme weather events, and we've seen many of those around the world, hurricanes and cyclones and so forth, that are extreme examples of extreme weather. And so therefore, trying to design to some of those values is what we need to do as best we can. Again, there's always some constraints like budget, of course, and timelines and so forth. But again, aspire as much as you can towards designing for extreme values. But also at the same time, one might want to make the resilience point is, we need to recover from these things. And so part of the challenge, and I think the solution, is to anticipate some of these things and to be able to recover quickly so that you can get the service and the infrastructure back up to speed. Next one. So there's different kinds of things here with respect to the climate. I'm not going to go through this now because we're starting to run into some time situations here, but I think the bottom line is working with a climate scientist, and these are some of the elements that you need to consider in compiling the climate information that you need for your design purposes. Go ahead, next one. So again, engineers don't work with just by ourselves or in isolation. We need to work with others, and in climate, we need to engage with a larger number of stakeholders and specialists to get the full understanding, particularly the impacts of climate. Sometimes, for example, having forest folks at the table can, in mountainous areas, could help in terms of, understanding the potential for landslides that could come down on infrastructure, that sort of thing. So we need to compose a team that's appropriate to the infrastructure and the location where you're located. Next one. And so there's a skill set that's needed to put this together. That's a multidisciplinary in nature, particularly risk, the whole risk element thing there mentioned. Knowing what the system is like or what similar systems are, the expertise, and then also engaging with natural scientists, hydrologists and that sort of thing. If you need hydraulic modeling, It's not necessarily an engineer that does that. A hydrologist could take care of that. Next one. Also, I think it's really important to work with operations and maintenance folks. If it's an existing infrastructure, they can give you the history of its response to past events, for example. And of course, local knowledge is really important. It's really difficult to engage a consulting company 3,000 miles away who've never worked in that area. At the very least, they should have local expertise and engineering expertise aware of that. Next one. Also important element of practice is communicating effectively. It's not just amongst ourselves, but we also have to communicate to our clients and the public. And we need to use language that is not engineering ease. It's simple, straightforward language. And particularly with respect to risks and the need to adapt to those risks and to do it in a plain language kind of format that they can understand and not get into super technical details. And that holds true with consulting with the public as well. Next one. The other aspect, of course, is service life, and these infrastructures last anywhere from 20 to 100 years. And if you can't convince an infrastructure owner or client that they need to think about life cycle, you're going to have a hard time convincing them about climate change because it's the same time scales that you need to think about. And you need to also think about a refurbishment. So sometimes an infrastructure will have a midlife rehabilitation, that sort of thing. So in your design, you can kind of plan for upgrading certain components to reflect the climate at the time. A good example would be air conditioning, where maybe you don't need all the air conditioning now, but 20 years from now, when it's hotter, you may need additional air conditioning. If you can account for that in your design, that's a great way of conserving some of the resources for when they're needed. Next one. So the one I'm going to spend just a couple moments on is around risk and risk assessment. And this really is, I believe, the important or the entry point getting into climate for engineers. And so we need to understand the climate risks and that sort of thing through additional engineering, to come up with a rationale for what the risks are and what we need to do about them. So as an engineer, you need to start to understand the risk science and how to apply it. And it involves consulting with a broad range of stakeholders. Next one. So again, plug for the PIVC protocol. This is a protocol developed in Canada to assess climate risk of infrastructure and the interactions between climate and the infrastructure. So it's a structured process that goes through. There's several products that are available, but and there's a website, pievc.ca, and I recommend you go to that website and check out. There's about 100 reports that use this protocol. It's been used over 200 times on 200 infrastructure projects. Next one. Just so you can see that there is a structured process to come up with the results, which include recommendations to deal with the risks. And it's an interactive process with a bunch of different stakeholders. So again, we could do a separate even workshop on this protocol. And there's a number of different products that they now have in the protocol, including if you have a portfolio of assets or if you have a green infrastructure, or if you want to do a higher level quick assessment. These are all products now that are available from the protocol. Next. And then, of course, the sort of unspoken thing about climate change is legal liability. You could be professionally liable if you don't consider climate change in certain jurisdictions, and just watch out for that. It's, in a lot of places that is not an issue really, but it could always be. If it's a private infrastructure, there could be potential. If you haven't considered climate change and then there's an issue from climate, you could be held professionally liable. So it's just to be watchful of that thing. Next one. And I'm moving on here quickly. Again, the next are two principles. One is resilience. We don't have resilience in the document right now because 10 years ago it was really not a concept very well developed, but now very much an objective for infrastructure to be resilient. So we're looking at incorporating resiliency and using adaptation to achieve resiliency. So and what we mean by it is designed to withstand climate impacts and the ability to recover and provide service quickly after disruption. So that's really the definition of what it is, and we'll try to include this in the updated document. Next one. The other one is nature-based solutions. The use of nature in infrastructure as an infrastructure solution is, again, a growing area, and there are certain applications that nature can be used. For example, coastal regions to handle sea level rise, storm surge. Next slide. There is interesting that it can reduce flooding, erosion, and drought. So you can kind of handle some of the effects of climate directly. Next one. You can actually use it in urban systems to reduce extreme heat. So, forest covers, canopies, that sort of thing in urban areas can reduce the impacts of extreme heat. So these are infrastructures that are natural in nature, and combining them with traditional infrastructure or applying them on their own, it's another solution to the toolkit that we can apply as engineers. And again, this is rapidly evolving, and I encourage you to monitor that. Next one. And we're coming out even with standards and that sort of thing. And they just literally published this a few days ago on coastal flood and erosion risk management. So using nature for that. Next one. So I guess just get to the end here, and I'm sorry I'm a little bit over what I wanted to be, but climate consideration is an important thing now for engineers. We all need to consider climate in our practice. It's just and it applies to most disciplines to varying degrees, but we all need to think about it. And it's, to get into that is really understanding your risks and vulnerabilities of the infrastructure. So when we started that work, it was like, how do we as engineers get into and assess and deal with climate change? And that's what we found at Engineers Canada, was that to assess and understand the risks is really the first step. And then once you have the risks and vulnerability profile, then you can adjust your design accordingly. And there's more and more demand for this, of course, with all the impacts of and damages and so forth in the world. The demand for this is ever increasing, and it's a fantastic opportunity for engineers to really get engaged in this. I think it's also the availability of tools and data. It's just exploded. So it's impossible to cover that in a 1 hour webinar. But I really encourage you to get into that, and we hope to provide at least a bibliography of sorts with the new update to allow people to have access to at least the top level or the top quality information and tools and that are available worldwide. Next one. And just to give you an example, this Intact Center that's in Waterloo, Ontario, they have a whole bunch of different tools and documents that can cover different topics. And I'd encourage you to check that, but there's lots of places in the world in countries that have these kinds of centers of excellence or centers of knowledge. And so I really encourage you to go to your country and your government and find out where these things are, and spend some time to see what's available, because some of this could really help you a lot in doing this. Next one. So it's almost here like a recipe towards climate resilient infrastructure. First of all, do a climate risk and vulnerability assessment. As part of that, also to develop your own capacity as an engineer to become familiar with this subject area and how to deal with it. Next one. and then consider it in all phases of the service life, the design, the operation, and maintenance. Obviously, bring in other tools, cost benefit, bring in asset managers, asset management. Really important to deal with operations and maintenance staff. They are the people that are on the front line, know what this infrastructure does and how it's been maintained and that sort of thing. And then, of course, we hope that governments will continue to commit to this through policies and legislation. Quite a bit of that has happened in Canada, and I believe in some other countries, but also just encouraging your country to do that. And of course, it takes money. So, but adaptation, I think one of the things that's misunderstood about adaptation is that they think it costs a lot of money. But if you look at it from a cost benefit kind of view, there's a high ratio of benefit to cost in adapting and making infrastructure more resilient to climate impacts. Next one. So a final statement that this code of practice, it provides a consistent framework, guidance for structured and fulsome consideration of climate in practice. So we believe that this document does that, and it'll be even better when we come up with an updated version. That'll be more an additional resource that engineers can refer to that's been agreed to amongst all of WFEO member countries. Next one is, I believe, a thank you. Is it? Trying to remember
Okay,
now.
thank you. Thank
All
you,
right,
David.
I apologize for going over, but a lot to cover, a lot to unpack. Hard to do it in an hour. So thank you for listening, and open to any questions either now or post webinar. Thank you.
Yeah, thank you, David, and thanks for the interesting sharing. And I will request maybe we extend another 10 minutes just to have some question and answer. Uh, from the chat, there few questions over there.
Yep.
Maybe we can. I mean, the first question is for engineers. As a climate change is not only for Canada, and it affects all countries, right? So how
Yes.
can engineer integrate climate adaptation in their regular practice and build resilience to that for the project development? I think that will affect quite a number of developing countries.
Right. Right. Well, I think it begins with, you know, I guess gaining that understanding, like taking, if you're just getting into it now, like take some training in it, get some familiarization with the issues and get familiar with climate. There are courses out there. We have some in Canada, but there's other places that offer this as well. Get into those, get to understand what the issues are around it, and learn, I guess, to begin. And one of the things is, it's a learn by doing approach as well. Like we found with doing climate risk assessment, we didn't even know how to do it at the early years, and we just you learn as you're learning as you. What do we need to think about? And we got people together and we got workshops together and had people talk to each other, and you're an engineer listening to these folks and what their concerns are and that. So I think that's sort of a place to start. And of course, finding like-minded engineers in your country that believe in this. You're particularly the national members. They would have, their registration bodies. So if they could offer some courses or that, or be supported perhaps through WFEO Academy, that would be really helpful. And then, of course, talking to government officials and what are their views. A lot of governments in developing countries do have national adaptation plans, and part of that is covering infrastructure. So meeting those people and offering to assist in their thinking and implementing, those could be some early steps.
Sounds like there's a lot of material out there. It's just like
There is.
you need to know where to get it, right? But then for participants who want to learn more about this, you can get to the reference. I think the last page, there's a lot of reference David has shared. So, or you can write to the secretariats of WFEO and we'll reach out to David to get those material to you or answer to any questions, right?
Absolutely.
Yeah. So if I go to the second questions on what happened to the existing infrastructure? I mean, the first question is more towards the new infrastructure, but what happened to existing infrastructure? Um, how can engineers build resilience to the existing infrastructure?
That's a great question. And I think existing infrastructure, you have an advantage in the sense that it's already been there and it's been, in a climate. And so there would be, some experience. What has happened when a big storm has come or a big wind? What has been the reaction of that infrastructure? So to try to diagnose, what's going on there or what has happened, that's talking to the operators, the maintaining maintenance folks, etc. As far as what can be done as engineers, we can recommend things like increased inspection. Sometimes, one of the things that kind of falls off in maintenance a lot of times is inspection. Oh, well, we'll do it, every 10 years instead of 5 years. Well, that's probably not a good idea because maybe something has materially changed. And so if an inspection also gives you a formal document that lists what are the, like a condition report, whatever, that can give you a notion of where are the weaknesses or if weaknesses have developed. So then that can make recommendations on how to rehabilitate that. Also, in existing infrastructure, often there's times when, we want to say a building, we want to update a building, for a change of use or that sort of thing. Well, that's a great opportunity to start to incorporate some climate considerations, like, for example, maybe better air conditioning or air conditioning, period. Like maybe in a lot of countries there's buildings that have no air conditioning, but if they're being refurbished or upgraded or change of use, you could start to you could introduce the notion of, well, we should have air conditioning there. As just I'm giving you a very precise example, but um, and a lot of things are also around like with adapting, and we found in understanding risks of existing infrastructures is things like training and policies and procedures. So some of it is, well, we've operated this way before, but maybe going forward we should be operating a little differently. And that could be, how you train your workers, um, uh, how do you do their shifts, or like an example I know of is where they want to have people near a dam for living near a dam in case there's any kind of a storm so that these people can still get to the dam if there's an issue, right? If they're like 20 miles away and the road is blocked and they can't get there, then maybe that dam is under, threat of failure because of from a big storm. So it can, adaptation and that sort of thing doesn't have to be expensive. It's not always just capital. It has to do with operating and maintenance, but it also at times will include, improving the design if you can, and taking advantage of opportunities. So that would be a starting point. I'd have to get into that more in an offline discussion to get into more details, but those are some initial thoughts.
All right, right. No, that's good. So I want to finish the last two questions, which is quite interesting. Uh, uh, the next question is what initiative can be undertaken to build the capacity of Ethiopian engineers and technical professional in climate adaptation and resilience? So we are referring to the Africa continent, Africa country, uh, what they can do in terms of training or in terms of building the resilience for them.
Well, I think I'll advocate for a moment of, I'm an associate of the Climate Risk Institute. So I'll just give that as an example and to say that that they offer courses in climate change adaptation, like risk and vulnerability assessment, asset management, risk management, climate law, procurement and policy. And you can actually get a recognition of that as a credential. And credential is a great way to sort of know that you have a certain body of knowledge. So and I know that the Climate Risk Institute is open to offering some of these courses. They do them remotely, and you can do them either as courses individually or leading to a credential, which unfortunately right now is limited to Canada, but the courses are available internationally, and they can be done remotely, and they have offerings. So that's a start. But then I think also important is to try and build capacity within the country. So you need some train the trainer kind of courses where we could get some folks in the country to become the instructors for that country. And that would require a process again of training those individuals, training them in how to teach, and then making those available within the country. Because one of the things that I think in climate is really relevant is you want to have local examples. Like it's great we have these courses, but a lot of the examples are Canadian. Okay, so if you don't have an example in the country, then it's less interesting. I mean, it's still helpful, but it's less interesting. So we need to develop, experience and bodies of knowledge of experience in those countries, and that's by doing it. Like, again, I would go to just because I know it the best, climate risk and vulnerability assessment. If we were able to do some of these assessments in the country on infrastructures within the country, that would be a tremendous starting point for building that knowledge base that's in the country, because then you'll have examples of what's happening there that you can then present in workshops, which is what we did in Canada. Um, and so it's kind of and you don't need we don't need to do 100 of these. We need to do a few, just so that you get enough of a sense of what is the issues are in the country and the infrastructures and where they're at. So I think that would be a great place to start, and that's what we did in Canada. We started off trying to deal with infrastructures, try to understand our risks, and once we had that understanding, then we were able to get onto, well, okay, what are the specific things we can do to mitigate those risks, right? If you don't know that, it's extremely difficult, because you're really just, you don't have the knowledge to do I think, a proper engineering solution, frankly, in my opinion.
Right. So, in the interest of time, so let us finish the last questions. The last question is probably I would say it's more of personal opinions, not
Yep.
representing any organizations.
Yep.
So, what do you think? What impact do you expect the move to reduce climate regulation in the US under Trump? It is definitely a disincentive to do all good things you recommend. Agree, or I think it's more personal opinions.
Well, I would call it cautiously optimistic, because what is really the issue there, I think, is the whole thing around mitigation, reducing greenhouse gases and what do you have to do that. That's a huge area that's, Mr. Trump is, we want oil and gas development and all this stuff, and it's going to produce more greenhouse gases. That 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 one is a pretty big elephant. I'm not quite sure how we could deal with that, other than we'll rely on our American friends to give reason to that. But on the other hand, the notion to adapt is an economic one, and I think the economic appeal of, hey, I can reduce my costs by um, doing this kind of work. Trump is a guy that, he understands that kind of thing, right? And I could even say, in Canada, we have, our government right now is very, very much embraces climate change and has supported it in a great great number of ways, some of them controversial, whatever. But back in the day when we had a previous government, they were, they wouldn't make commitments to mitigation targets and all that, but they supported the notion of adaptation. We had very good support through the years to actually look at, how can we adapt our infrastructure to climate. So I think there's a really strong argument to make for this because it's not just, some thing that everybody's arguing about, and we can't seem to come to any consensus about what it is and how to do it and all that, which is the mitigation. On the adaptation, you can do it in your country, in your community, and there's an economic argument to do so. The benefits are there, and I think that will appeal. We got to make the right arguments in the right places, and that not just the U.S. but everywhere. But I think there's a very strong case to be made, especially in light of all the events of the world, all the terrible impacts, hurricanes, and so forth that have happened, and they're happening more and more severe. People can't deny that these are happening, and it's if you talk about it in terms of extreme weather and not climate change, people actually relate to that much better. So I think we need to use the words like extreme weather rather than climate change because it just everybody has their own idea of what climate change is. And but they know what extreme weather is and that we need to deal with that, and we don't want to have all our buildings smashed to the ground and not have power for 7 weeks and whatever. And we need to take steps to do that. And I think the public understands that, and I think governments can understand that. And of course, engineers are central to making that happen. That's my cautiously optimistic view.
That's good. That's good. Yes, thank you, David. And receive a message from the Secretariat saying that this webinar is recorded and will be available in the WFEO website. So for those people who are not able to participate or you want to listen to what David is sharing, so you can go to the WFEO websites to do to listen to the recording. All right, I think in view of time, so I would think that we'll end this webinar. And thank you again, David, and have a good day. Thank you.
Thank
Bye.
you. Bye bye now.